I want to hear your questions because you don't know which questions you still have and which questions they you could answer. But if you have worked on them and if you have gotten stuck, question, where have we gotten stuck? Ready, set, go. Bridget.
14 and 15.
14 and 15. Angela. 10, you go back and get them.
17 and 15.
17 and 18. Yeah. Ella, what else do we got?
3 and 6.
3 and 6?
Yeah.
Haley, what do you got? And I'm going to be using you guys to help me out, so make sure that you have your work in front of you too. I'm going to have you explain some of these if you can. Angela, that's 30.
29.
29 and 30. 30 is one that I've officially never seen on an MVP before, but it was on both the practice AB question and BC questions. So we will talk. It is technically a photo card, but we'll definitely talk to them in 30. I've never seen that on an AB before, but they are kind of changing it to be more concept-y this year. So that's cool.
No, I didn't know. I could guess.
Anything else?
I could guess this book.
1 through 30?
All of them.
No! They're smiling looking at me.
Okay, 24.
Oh, this one.
Yeah.
Okay, in part B, let's go over there because we have a lot of questions here. Part B. It's a Loki Towels one. Alright, part B, starting with number 76. Alan.
76.
What else? Andy. What else? Alan.
34.
Anything else? 81. Start saying it. Go like, yes, yes, yes. Ella.
Can we do 79 and 92?
Oh, I got something I did, and I didn't do. Oops, that was too. I don't think there's a 90. Oh, 90 also?
Yeah.
Got it. Got it. Alright, let's go ahead and just start because we have a lot of stuff to do. I think that my recorder is going. Let's go back to part A. Now guys, I am going to save this work online, so I'm not promising that I'll get all the way to the answer, but you know what the right answer is, and I will get as close as I can, using you guys as resources, okay? So, number 3, some of you need to learn how to read these questions, and hopefully you've been working on them. As soon as you see this, I need you to think it's just, or they are just clues. Ignore them until it's time to plug in. They are just clues. I need you guys to realize what they're asking is approximate at 2.1 the function using the tangent line. Question, kiddos, how do we do a tangent line?
Y minus Y1.
And y1 can be found by plugging in the particular x value, which in this case is 2 because they said at 2. So y minus f of 2 equals f prime of 2 times x minus 2. This is literally a tangent line. The derivative is the slope, the function value is the y. So we plug in from our clues up above. We know what that guy is, we know what this guy is. But wait a minute, how do we do this?
Plug in 2.1 for x.
Oh, 2.1 is the next value, so all we gotta do is plug in 2.1. So we have negative 1/2 times 2.1 minus 2. You guys got stuck in the math? Well, it is what it is. But 2.1 minus 2 is just 0.1, which is the same thing as 1/10 if you like fractions. 0.1 times 0.5 or negative 0.5 would be negative point, move the decimal one place. 0.5, or if you did decimals, you have 1/2 times 1/10 is 1/20th. You could have done 20 into 1 and you would have gotten 0.05 by long division, if that helps. But if you guys think about it, this is going to be negative a little value right here. Plus 4, it's going to be a little bit less than 4. The only one that's a little bit less than 4 is the second one. Is letter B. So you didn't even necessarily need to exactly solve. Just think you have a negative little value plus 4. The answer is going to be the one that's a little bit less. Alright, that was all about a tangent line. Number 6, I have a table. Given R, which is tons per hour, which is a rate. Yes, you need to read the entire question. But the recycling center, all that is just to throw you off. We have something in tons per hour. Trapezoidal sum, 3 subintervals. The approximate number of tons of material deposited in the first 9 hours, meaning between 0 and 9. Approximate how many times, which means integrate, but we can't, so we'll do the trapezoidal sum instead. What's the area of the trapezoid? The very first thing you should see when you see trapezoid.
1/2 base times height.
The bases are found by change in x's. The heights are found from the y values. So what is the change in x for the first subinterval? 2, because that's the distance in x's. So I have 1/2 times 2. Height 1 plus height 2 are the 2 y values, 15 plus 9. For the second one, 1/2 times, what's the base for the second one? 5. 7 minus 2, that's a distance of 5. Using the 2 y values, which would be 9 plus 5. Last but not least, 1/2 times, what's the last jump's distance for the base? 2 again. And I have the heights of 5 plus 4 from the y values. Are we tracking?
Yeah.
Using delta x's, or in this case t's for the bases. The y values are from the table itself. Yeah. So then as I go all the way down, I can pull a half out of everybody. And I have 2 times 15 plus 9 is 24, plus 5 times 9 plus 15 is 14, plus 2 times 5 plus 4 is 9. Yes, it's a little bit annoying because you just gotta go for it. If you want, you could multiply this little half in and simplify all of your math. A half times 2 would just be 24. A half times 14 would be 5 times 7 is 75. And a half times 2 is just 9. That would end up being 5968.
Okay.
Yes, I know, there's math involved. But it all comes back to, do you know how to set up a trapezoidal sum? Okay? Alright. Number 7 we already did. Number 9. I know there's a piecewise, but they're asking us to find an integral. This one was a little conceptually difficult, won't lie, totally in tracking on this. However, integral means what in terms of like a graph? Area under. Area between a curve and the axis, right? So if I'm trying to do area under from -5 to 3, question, which part of my piecewise am I using? The top one where x is everything but 0, or the bottom one where x is 0? The top one. Now some of you are like, but you have to split it up at 0. You can split it up at 0, but the point is, question kiddos, at 0, is there any area just at 0?
No.
No, it's infinitesimally thin. There's no area. It's just a straight line. So does that little part of the piecewise make any difference whatsoever as far as adding or subtracting area? No. So in essence, we can ignore that and say area needs to be over a time interval, from one time to another time. At 0, there is no area for me to deal with at a straight line. I need to deal with all the rest. And all the rest says, okay, cool. So just use the function from the top. So I'm going to do -5 to 3 of absolute value of x over x, which is the same thing as x over absolute value of x. It can be on the top or the bottom. And this is a little rough unless you guys remember, hey, what is the derivative of the absolute value function? That thing. The absolute value can be on the top or the bottom. It's the exact same thing. So some of you might want to go to your forever cards and be like, hey, the derivative of absolute value of u is u over absolute value of u, or absolute value of u over u. It's the exact same thing. Sorry, times u. If we were taking a derivative. integral goes backwards, so it's like, oh hey, that's the absolute value derivative. Let's just go back to that. And we can go between negative 5 and 3. So we have the absolute value of 3 minus absolute value of negative 5, which ends up being negative. Yeah.
If there's a discontinuity at 0, can you still take the integral of it?
Yes.
Really? Okay.
Yes. Now, if it's a vertical asymptote, and so the area is increasing, we have to use something called an improper integral from Calc 2 or Calc BC. But if it's just a point discontinuity, like it's literally just like a let's go, and then a hole, and then let's go.
So this one isn't like that. It's the jumpy one, right?
Right, it's not an asymptote, so it's not an infinite.
Mm-hmm.
So there's still an actual area. Does that make sense? Because if you were to graph absolute value of x over x, it would be
Be like a line, -1, and then it jumps +1.
and then positive 1.
Yeah.
So we're going between negative 1, 2, 3, and 1, 2, 3, 4, 5. The area under would still be what we found over here. They said, hey, and by the way, there's a point at 0, 0. But that doesn't make a difference.
Okay. Yeah.
Okay, number 10. Oh, it's U sub! Guys! Did you get your U bound? What happened? If U equals 2x minus 1, doesn't that kind of make sense from looking at the integral? U is the inside?
Yes.
Okay, what's du? We know how to do this. Du is equal to 2dx, and then I need to go ahead and solve for dx by dividing, right?
Mm-hmm.
Okay, then we plug in and we say, okay, the integral of g of u times, plug in dx, and we get 1/2 on the outside, du inside. But the problem is, can we just use the 2 and 3 bounds again?
No.
No, because those are x bounds. How do we find u bounds? U of 3 and u of 2. U for this. U of 3 and u of 2. Plugging in 3, we get what, 5? Plugging in 2, we get 5. And that matches with which answer? U bounds. U bounds. U bounds. Number 11. Oh, I love this problem. It was a great one. Kiddos, shade. They asked me for the integral. You guys already told me that's area what? Under the curve. Well, area between the curve and the axis. So between the curve and the axis, wouldn't it be this area up above? The problem. That's not a geometric shape. But what is geometric? A rectangle. And what else is geometric? A semicircle. This is an old school SAT rectangle minus semicircle question. Look at that. Look at them bringing the SAT math back. So you have to go ahead and do rectangle minus semicircle. Actually, I guess technically it'd be the other way around. Because the area below is going to be a negative number. So we could do rectangle as a positive area minus semicircle as a positive area with a negative and say, wait a minute, it's area below. We could do that. The rectangle is how wide? The ideas are right, 10, and then how deep? 6? 10 and 6 to be 60 is the area of my rectangle. Bless you, bless you. My semicircle, what's the area formula of the semicircle? 1/2 pi r squared, and what is r? Half the distance. If the whole thing is 10, yeah, then it's going to be 5. 5 squared is going to end up being 25. So a couple different ways of writing it, but long story short, if we distribute the 60, we have, or the negative, we have negative 60 plus 1/2 times 25 pi, which is the same thing as, which one? C.
Misty.
Yeah.
How'd you get to 5?
Oh, because the entire length is 10, and the entire length is the diameter. So then the radius is 2. What do you guys do in number 12 when we start talking about what is its position and they give us acceleration? And if you guys started saying 1/2 acceleration times square plus initial velocity times time, you did not realize they did not give you a constant acceleration. They gave you a variable acceleration. What do you guys do? Integrate. Have to integrate. That little 1/2 a sub naught t squared plus b sub naught t plus s sub naught only works when acceleration is a single constant number. Since acceleration is 16, we have to say to get to velocity, integrate that 16. You end up with, what did you guys get in that first integral? We got 3t squared plus, and then there's a c, right? So what did they give us that we can use as a clue? Yeah, they gave us velocity at 0 and position at 0. So plug in 0, long story short, c ends up being 10. T is 0 when v is 10, you plug in, and c is 10. Then how do I get to position from velocity? Integrate again. So f of t is equal to the integral of 3t squared plus 10. And as I integrate yet again, I will end up with, double check my integrating, another plus c, right? But good thing I have another clue. So if I plug it in, I get x of t is equal to t cubed plus 10t plus my initial position is 7. And they say plug in 2, so 2 cubed is 8, plus 20 is 28, plus 7 is 35. All we have to do is plug in 2. Finish the question. Brendan, your package should be open. You guys should be correcting, because I doubt that you have every single one totally perfectly down. And the rest of you guys, you can get in there. I know it's hard, but the air is on, so you should be trying to stay in there. All right. Number 14. They did not give this to you very, very clearly, but they did say G is an antiderivative of f. If G is the antiderivative of f, that means when you integrate f, you get G. They kind of gave us the hidden clue. G is what comes out when you integrate f. This is the age-old, let's see, there's an x up top, and then I'm going to put 2 down bottom because they give us a starting point when x is 2. This is one of those accumulation functions that we see in FRQs sometimes. So then they say, hey, if we know that at 2, G is 5, how many times is G of 3 going to hit 3? Sorry, G of C going to hit 3? Well, to start at 5 and get to 3, don't you have to decrease, guys? But decrease how much? Well, if G is the integral of f, how do we think about an integral if we're given the graph of f? Oh, hold on, you guys just answered this a second ago. Integral of a graph, what is it? Area under, or area between. Okay, so area. If we were to find the area, I see an area block here, right? I see an area block here, that's going to be a negative. And I see an area here, all geometric. For those of you guys that already found this, what was the area of the left triangle?
2.
Area of the second triangle?
Okay, give it 3.
3, and technically it's a negative because it's below, and then the last one?
2.
2. Okay, so at 2, which is this point right here, at 2, G starts at 5. As I move to the right, it's going to start subtracting, 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 and what is it going to end up subtracting in total? Yeah, it's going to subtract 3 as I go from 2 to 5. So in between 2 and 5, if I do 5 minus 3, question, is it going to have to cross through 3? Yeah, because 5 minus 3 is what? 2. So it's going to have to cross through 3 once. So I'm just going to do a little a tally mark. So there's going to be 1 for this interval as I move to the right. So if I start at 5 and I'm subtracting 3, by the time I get here, I have gone through this one. Because 5 minus 3 is 2. I've gone through 3. What happens when you go backwards in a graph? Am I adding 2 or am I subtracting 2? I'm doing the opposite, because if you have to flip your bounds and subtract. So as I go backwards, well, question, guys, what's 5 minus 2 as I go all the way back to 0? Oh, okay, so it's 3 at 0. Does it say you can include 0? Yeah, okay, so as I go back to 0, there's a second one. Backwards and subtracting 2. What was there any other time? Okay, 5 minus 2 is 3. There we go. 5 minus 3 is 2, and there's going to be a 3 in between. What's 2 plus 2 as you keep going? 4. Well, in between 2 and 4, you're going to hit 3 again? Yes. So as you keep going, you'll hit 1 more time. So how many total? Did I figure out exactly where they happen? No. I can just tell that as I start from 5, and as I subtract 3, subtract 2, subtract 3, and add 2, I'm just thinking, oh, it's going to have to pass through 3 different times. A very concepty question. Very concepty question. Number 15. Oh. Isn't this one a lot like the packet that we did on limits and continuity?
Yes.
So now I'm going to explain this one. You guys need to go back to that packet if you didn't understand it. It says that, the question says, f is continuous. If f is continuous, that means as I come from below 1 and above 1, plugging in 6 plus c times. Below 1 and above 1, the limits have to be equal, meaning I should be able to plug in. And both sides, both pieces should agree. ln of 1 is 0. That all goes away. I end up with 9, 6 plus c, so therefore c is equal to, go back to that packet, limits and continuity, piecewise function. Number 17. We actually did things like this in our book. I'm so glad I used our book, because if I used last year's book, it wouldn't have had these types of problems in it. And they're expanding the types of AP problems this year. How can I tell whether or not this guy works and which one he works in? Test it. Find his y prime. Find his y double prime. They're all in the equations. Y prime equals, what's the derivative of e to the u? E to the u times u. What's the derivative of negative 5x? And what's y double prime? 3 e to the 3x times another 3, so it's going to be 9 e to the 3x. Derivative of 5 is just 0. Alright, well, which of these works? These ones aren't going to work. Because if I do y double prime minus y prime, that is not going to end up equaling 0. Because these two terms don't match. So those definitely don't work. Alright, now in between a and b, and both of them start off with y double prime, so I'll write them in. Minus 3 times y single prime. I'll figure out whether I need a minus 15 or a plus 15 to make 0. So I have 9 e to the 3x minus 9 e to the 3x plus 15. What do I need to make 0? I need a minus 15. So I'm choosing it. There is no solving of this one. There is solving in the sense of looking at the pieces that are in the problem, finding those pieces, and then just seeing how to put them together. So long story short, you could have done y double prime minus y prime and seen that it wasn't going to be 0. That's how I canceled those two out. If you do y double prime minus 3 times, then you see these two match. They'll cancel, but I needed a minus 15 to cancel with the positive. Bridget, did I answer your question?
Yeah.
Oh, we just don't like the unit circle on the 18. Whoever asked that one. We just didn't like the unit circle. Kiddos, you were studying your forever cards. What's the derivative of sine inverse?
1 over square root 1 minus
1 1 minus u squared times u prime, that's just an x. So 1 minus x squared times x prime is just 1. All we gotta do is, all we have to do is plug it in, right?
I was getting confused with the square root and the fractions.
Yeah. So it's the simplifying thing. It's not even trig, because trig goes away. So then we have square root of 3 over 2 squared. How do we square that expression? Square root of, square root of 3 squared. They just cancel out, you get 3. And then 2 squared? 4. So we have 1 minus 3/4.
I see.
I would have gone ahead and got the little common denominator. Then you would have had 1 over the square root of 1/4, which ends up being 1 over 1/2, which is 2. Does that make sense? Okay, sometimes it's just the math. Ooh, what's going on with this guy? When you plugged in, what happened?
0.
0 over 0 means what?
Keep going.
Keep going. How do we keep going?
L'Hopital.
Hey, look at that. So L'Hopital says, okay, well, since it was 0 over 0, we can go ahead and the limit of the, the derivative of the top, derivative of the bottom. What's the derivative of tangent?
Secant squared.
Secant squared of u times u prime, but that's just 1. All over 3 e to the u is 3 e to the u times u prime is just 1 minus 1. What happens when we plug in 3 this time? We have secant squared of 0, which we'll get back to in a second if you hate your unit circle. But plugging into the bottom, 3 minus 3 is 0, e to the 0 is 1. 3 times 1 is 3, 3 minus 1 is 2. Oh, it's not a 0 anymore. What's secant?
1 over cosine.
1 over cosine. So what would cosine of 0 be? Cosine of 0 is just 1. So then I end up with But if you notice, kiddos, as soon as you got the 2 in the bottom, even if you hated your unit circle, as soon as you got the 2, couldn't you say, well, it can't be 1/3? It can't be DNE because it's not divided by 0. You have a 50% chance of getting it right. That's better than the 25% you have. G is the inverse function of f. Our forever card says to find the derivative of the inverse. F inverse prime of A is equal to 1 over, finish it,
F prime of B.
F prime of B given F inverse of A equals B, or F of B equals A. That might be something that you might want to add to your forever card. I don't remember if we wrote it both ways. Yeah, I didn't think we did that both ways. So, both ways can show up in a forever card. They can give you this clue to work with or that clue to work with. That might be a good thing to write down. So long story short, when they asked us for g prime of 2, and g is the inverse, then I know I need 1 over g is the inverse of f. But am I plugging in 2 to my derivative? No. What am I plugging in? B. And what is B in this problem? A is 2 and B is 0. If it helps, you could go ahead and rewrite the problem and say, okay, what I'm trying to find is f inverse prime of 2. That's what's going on when they give you g of 2. And this is f inverse of 2 equals 0. If you don't like the g notation, you can go to the inverse notation. And that might help you see a little bit more clearly why 0 is B. But then all you have to do is just find the derivative of f, which is 3 somebody squared plus 4, plug in the 0, and you end up with. So plug in the 2, plug in what goes with the 2.
What's the one where you have to like set them equal to each other and solve them, and it's really confusing?
It's this one, but they would have given you a different clue. If they hadn't given you this right here,
If they didn't give us that?
if they didn't give you that, then you would have had to go looking for this guy, and it would have said set f of x equal to a, so we would have had to set x cubed plus 4x plus 2 equal to 2, and
that
then you would
was
have guessed. X equals 0. Oh, hey, it works. Cool.
okay.
If 0 didn't work, you would have tried 1, you would have tried 2, you would have tried 3. Yeah, so it's this type of problem. You set equal to.
Because that's what I was.
Trying to do.
Yeah.
Yeah. And it does work.
Well, I forgot how to do it first.
Yeah. Let me see if I can get rid of that.
Thank you.
Okay, so I'm just going to put little parentheses around that and say that is another way to solve it. Okay. Alright, last one for non-calculator. Attention, they put this practice problem on here for a reason. They're trying to test concept-ish stuff. Kiddos, we have this in our forever card. It's the definition of an integral. The limit as n goes to infinity of the summation k equals 1 to n of f of c sub I times delta x sub I equals the integral from a to b of f of x dx. Okay. How do we take that forever card and how do we figure out this problem? Question, think Riemann sums. How do I find delta x if I'm allowed to find it? Delta x, I take b minus a all over n, right? I take b minus a all over n. Well, who's my b? 5. Who's my a? 2. Cut it into n pieces, and if the Riemann sum, if they wanted 3 subintervals, n would be 3. If they wanted 5 subintervals, n would be 5. But are they plugging in for n? No, they're keeping it. So question, what does my delta x need to be? Not 1 over n, 3 over n. I've gotten down to a 50% chance. And then as we go to plug into my Riemann sum, f of c sub I means I need to be plugging into x squared. So far we have the limit as n goes to infinity. The sum k equals 1 to n of something squared times 3 over n. We are almost there. So we know we need to plug into my function. My function is what's in the integrand. Integrand was in the integral. But what do we plug in? Delta x tells us our base, but it also tells us the jumps. The jumps in like a table if we were to make one. Delta x tells us the jumps in the table. Question, which function between b and d is jumping by 3 over n's?
D.
Why d?
Does the 3 in front of the k?
If you plug in k is 1, you're doing 2 plus 3 over n. K is 2, you're doing 2 pairs or 2 sets of 3 over n. K is 3 sets of 3 over n. D is using 3 over n, so D is correct. When you plug into your function, you would be moving by delta x's. The 2 plus is their way of saying like start at the left endpoint and then you add however many 3 over n's you need times k. I'm not necessarily expecting you guys, and neither is the AP expecting you guys to totally come up with this all on your own and have it all memorized. Maybe I'll be a little more particular showing how the definition of an integral works next year. It's never been tested before. But you guys could have gotten there with your delta x that we've learned from Riemann sums and the idea that 3 over n is what needs to get plugged into the function as well. Okay? Non-calculator, done. Calculator, we only had a couple questions. We had 2, 3, 5. Alright. Kiddos, for free response, where do you go for help? The videos online. If you have any extra questions, we might go over this. I will show you what you need to plug into your calculator. Sand is being added to the beach. And question, is this how much sand or is this how fast?
Oh, how many? How
You guys
much?
know that the waves like take away the sand and then the beaches decrease. Anyway, that's what's weird. So they're adding sand back to the beach. This is how fast, tons per hour. Since 5 a.m. How many tons of sand are added to the beach over the 3-hour interval from 7 to 10? Well, how do we get to tons from tons per hour?
It's great.
And are they asking for an over, just a plain old definite integral, or an at, an integration is net change? Over. It says over. So we literally just have to go, wait, did we do 7 and 10?
Nope.
Nope. It says since 5 a.m. So how long has it been at 7?
2 to 5.
2 hours. And then at 10 it's been 5 hours. So literally all we have to do is the integral from 2 to 5 in our calculators, plug in S of t dt, and my guys, they got it right. What did your calculator spitting out?
Hey,
Just take the integral. Could have messed up on the bounds, could have messed up on what to do. Number 79, we have a graph of velocity. Ooh. We gotta pull that out right away when we're doing it. We know that displacement is 3. Displacement is 3. And total distance is 13. And they're asking us for the integral from 2 to 4. They're asking us just for this area. Are you guys okay if I say something like, let's name this A, B, and C? Okay. And for displacement, I'm going to say really quickly, well, you can see it that way. Displacement says keep all the signs the way they are. So the A minus B plus C equals 3. But total distance says no. Keep everyone positive.
So we're not supposed to.
There's no integrating because there's no geometric figure and there's no function for us to actually integrate. So it's literally saying, well, whatever this area is, minus whatever area this is, plus whatever area this is, that's displacement. But if we make B positive, that's total distance. Sorry, that's 13. Now wait a minute, we're algebra students. How do we take a system of 2 equations and solve? You could do substitution, or you could do elimination. So we could just line them up. We could say, hey, let's just subtract everybody. A's cancel, C's cancel, and get negative 2B is equal to negative 10. That's a 13. No, what's a 13? So I get that B is equal to 5 as the area of the question, kiddos, as I go to answer the question. Looking at B, is it above or below? Oh no, so I'm going to answer negative 5, right? The integral is negative. I was just finding the actual number itself. There's different ways you could have set this up. I just thought that was the most, I guess, logical. Well, it's like the whole entire thing, isn't it? You have a derivative. I'm just going to do a quick sign charts because it's easier for me to think about. At 0, there's a discontinuity, and at 1, there's a 0. My derivative is above, before, above, after, below. There needs to be a maximum at 1. A maximum at 1. And my function needs to be increasing. I think that only works with A.
Yeah.
Because you're increasing. So I used my 0 and my D and E as my critical numbers. I saw that my derivative was above, so positive, above, positive, below, negative. My function needs to be going up, and then going down. This is the only one that goes up, and goes down.
Wait, did you try that carbon one?
From my sign chart, I need my function, my graph to be increasing, and then increasing, decreasing.
Oh.
This is the only one that
So you
increases.
just look at the signs. Okay.
Look at the signs to help us out. Whew, man, kiddos. We basically got there. Tomorrow at the very, very, very beginning, if you guys still have questions on those last couple, and I'll see how you guys did on the FRQs if you have any good questions. Tomorrow we're going to be going through the integration techniques. So you don't have to have this done. But if you are, like I'm pretty much done with the questions besides a couple of questions, you can read openly. Pass that. Pass your back. And this is for you guys to read. You can at least read the intro material for integration techniques. But some of you are like, yeah, my journal's over now. Quoting due by the end of the day, kiddos. I'll see you later. TGR, you guys are looking at
Is there a bell honey at lunch?
did you get the group?
No, I didn't. You only
Let's
get.
see birthday today, so some of you are figuring out
Our high school lunch?
Yeah.
Alright, cool.
It's right there. I mean, it's spicy. No, it's not. It's too early for that.
Those things you just passed on. New one.